In this video, we'll generate the hyperbolic cotangent and its Taylor polynomials using infinite product series. So we begin with the dataset of the hyperbolic cotangent, which is equal to array formula. Hyperbolic cotangent of the x values from 0.2 to 1.8. And the infinite product series expansion, which is 1 over x times pi, big pi, of 1 over 1 plus x squared over pi squared over n minus 0.5 squared, all over 1 plus x squared pi squared n squared, where the value of n is from 1 to infinity. So we can start with 1 up to infinity. 9 is good enough. Now we continue with the array, which is array formula, starting with the denominator. So that is x divided by pi squared n squared. So pi times n raised to the power 2, or squared. That's squared. Next, we continue. We factor in 1 plus. So again, this will be 1 plus. 1 plus. That's the denominator. We continue with the numerator. They're the same except that the value of n here is n minus 0.5. So we copy the denominator. We copy that and enter Control V. Enter. Now that we have entered both numerator and denominator, we modify n here. From instead of n, it will be n minus 0.5. So this will be n minus 0.5. And enter. Now we continue with the infinite product. So this will be product of these values from n equals 1 up to infinity. In this case, 9 is good enough. And this is divided by x, so multiply by 1 over x. So this will be divided by x. And we drag this downwards. And we chart this. Insert chart. And we use scatter chart. Use column as label. We don't need the title, but we show the equation. So under series, click the trend line, the type polynomial, and the degree 8. For the label, use the equation. So here we have the trend line and polynomial, the Taylor polynomial of hyperbolic cotangent. Let's compare. So they're all in the same trend line, they're collinear, and their polynomial regression coefficients are the same. So 14.1 x to the 0 minus 80.5 x, 249 x squared minus 464 x cubed, 545 x to the 4th minus 407 x to the 5th, 48.4 negative 48.4 x to the 7th, and 53.8 or 5.38 times 10 to the minus 38 value. So they're exactly the same and their polynomials are exactly the same. This completes the use of the infinite product series to generate a Taylor polynomial of hyperbolic cotangent.